Hello, this is Anand from Math channel. In this video, we're going to take a look at a geometric problem. We have a triangle which its perimeter is 24, and we're supposed to find out which one of these numbers can be the longest side of this triangle. So stay tuned and watch the rest of this video. So what I'm going to do is to talk about a beautiful property of triangles. I'm going to prove the property, and then I'm going to use the property to solve our problem. So let's say we have a triangle, a scalene triangle like this. So first of all, let's go ahead and denote the vertices of this triangle. Let's say this is A, this is B, and this is C. And respectively, this side, the opposite side to the angle A, we can call it A, this is C, and this is B. And let's suppose that A is the largest side of this triangle, so we can say that A is greater than B, and also A is greater than C. And it is obvious that the perimeter of this triangle, P, is A plus B plus C. So I'm going to use this given information to come up with a beautiful triangle property. First of all, I'm going to add these inequalities, and I'm going to get 2A is greater than B plus C. And now, by adding A to both sides of this inequality, I'm going to get 3A is greater than A plus B plus C. And guess what? A plus B plus C is the perimeter, P. So, 3A is greater than P. And now, by dividing both sides by 3, we're going to get A is greater than P over 3. And this is true for any scalene triangle. The largest side of a scalene triangle is greater than its perimeter divided by 3. And now let's go ahead and call this inequality number 1. And then let's go ahead and talk about the triangle inequality theorem. Now, what is the triangle inequality theorem? The triangle inequality theorem states that in any triangle, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Which means, in this triangle, we can say A plus B is greater than C, A plus C is greater than B, and also B plus C is greater than A. So all of these inequalities are true for any kinds of triangles, based on the triangle inequality theorem. And what I'm going to do is to use the third inequality, and I'm going to try to come up with another relation between the perimeter and the largest side of the triangle. So we have B plus C is greater than A. And now, by adding A to both sides, I'm going to get A plus B plus C on the left-hand side, which is the perimeter. And that's what I'm going to do. I'm going to add A to both sides. So I would get A plus B plus C is greater than 2A. Which means the perimeter is greater than 2A, which means P divided by 2 is greater than A. And let's go ahead and call this inequality number 2. Now, we can go ahead and put both of these inequalities, inequality number 1 and inequality number 2, together. And if we do that, we're going to get A, the largest side, is greater than P over 3 and is less than P over 2. So we have found out this property. The largest side of a scalene triangle is always between its perimeter divided by 3 and its perimeter divided by 2. Now, in our problem, the perimeter, P, is 24. So, based on this property, we can say that the largest side, A, is between 24 divided by 3 and 24 divided by 2. So A is a number between 8 and 12. Now at this point, let's take a look at the answer choices we have. The first one, 5, is eliminated because A cannot equal to 5 because A is greater than 8 but 5 is less than 8. Because of the same reason, the second one is eliminated too. The third one can be true, so we keep this one. And the third one is eliminated because 13 is greater than 12, but the largest side of this triangle must be less than 12. So A is 10. But notice that the most important part of this video wasn't about finding the value of A. It was about this property. In any scalene triangle, the largest side must be less than P over 2 and must be greater than P over 3, where P is the perimeter of the triangle. Thank you for watching this video. Don't forget to click like and don't forget to click subscribe if you liked this video and if you enjoyed this video. Goodbye, I'll see you later.